Hello there. So I thought I would give you a preview into Cerebral 2. We are closing in on release and a few things has changed. Like the release of Cerebral 1 was really like the celebration of an experiment. And Cerebral 2 is more a purification of that experiment. Like Cerebral works, it's a good tool to build complex applications, but there was huge room for improvements on the API. And we tried many different solutions. And we have kind of like landed on a few where there were options, there's no options anymore. Like this is the best way to do it. So there's been tons of iterations on this project, and I thought I would give you some insight into what we have landed on for Cerebral 2. So first of all, the API of Cerebral 1 was very like imperative. And as you can see on the left side for Cerebral 1, you had to create a controller, and then you would call methods to add signals, to add state, to add modules and stuff. That's no longer the case. You just create the controller and you kind of configure it. It's a declarative approach. Also, as you can see on the next release, there's no model anymore. We tried many different kinds of models for Cerebral 1, and what we landed on was our own model, a very simple model layer, which I will talk a little bit more about later. So let's move on to how you connect Cerebral to your components. In Cerebral 1, you would have an object, like you call connect, and the first argument is an object. On the left side, you see that we attach items, and it points to the items path in the state tree. And then you would have access to items inside your component, and you would also have access to the props passed by the parent component. To trigger signals, you have this special signals prop where you would have to point into like the module of the signal you want to trigger. And if you wanted to kind of like, in this case, I wanted a specific item based on the prop item key passed by the parent component, you really had to do that inside the component. And this actually affects performance and stuff as well. Anyways, on Cerebral 2, you still connect, you still pass an object as the first argument, but you use something we call tags. So you explicitly say, I want this state or I want this signal into my component. The cool thing about tags is that they are template tags. So you know the template literals you can use to kind of compose together strings. They also have a tags functionality, which means that we kind of like we call the tag as a function, and instead of calling it with parentheses, we call it with a template literal, which allows us to do some really cool stuff. So in this case, we are saying that we want a specific item, and we want that item by pointing to the item state, and then we kind of compose in the props of item key. So props here points to the props passed into the component, and state points to the state inside, like the state tree of Cerebral. And this is a declarative approach, which we favor a lot in Cerebral. And the reason we favor declarative code is because that is something that the debugger understands. It can kind of like analyze it. And also you explicitly say, I want this signal. So the point here is that it makes it easier for you to understand, okay, this component connects to Cerebral, and what it gets from Cerebral is this state and these signals. And then you can look into your component code. So it's a very readable way as well, or it increases readability as well. That's what I mean to say. Cool. When it comes to signals, they are basically the same concept, but we have these tags that I talked about. Those are also available in signals. So on the left side, we have like copy, and we have these special strings for kind of pointing to what we call input and state and all this stuff. But now we can use these tags instead. So it's the same concept. Like we say, we want to set some path in the state. And again, we use like template literal composition to tell it to insert some state on a specific item. And then we say props data, which is the value we want to set. Yes. So this just allows you to do more with the operators. Having this composition possibility, you don't have to create an action for every dynamic little thing you want to set. Like if we wanted to do what we do on the right side here in old Cerebral, you would be forced to create an action, a new file with a new function and all this stuff. You still have to do that in Cerebral too, but you don't have to do it as often. And this just tells you what it does. And then we don't have this array inside array thing. It doesn't really help for readability, and it actually had a couple of bugs and made it impossible to handle certain scenarios. Now instead you use explicitly parallel. So when you use an array, you have a sequential execution of actions. But when you use parallel, then you have a parallel execution of actions. And the really cool thing about this is that you could actually import sequence here as well and export a sequence of actions. So using an array literal is just a short for using sequence. But when you explicitly use sequence and parallel, in this case, you can actually name them. And that's something that the debugger understands. And I will show you that later. And then we have compute. Like typically you want your state tree to be it should look more like the database than what your components want. What you use compute for is to translate the state of your state tree to exactly what the component wants. If that state needs to be combined in some way. So on the left side, there's an example from the current website of Cerebral, where we basically want to sort some items, and then by date time, and then we want to filter them. So you had to do this inside one computer before. But now we have a different API which encourages composition. Like composition. That's the good thing. Like reuse code and all this good stuff. So the point is that on the right side, we just compute first, okay, we want some items, and then we put in a function, and that function will receive these items. And then it just sorts them and returns them. And then we want the filter, or the current filter from the state tree. And then we run a function called filter items. And this function will now receive the sorted items from sort by datetime, and it will receive the current filter. So it can do the filtering. That means that we could actually we could even create like our own compute of the items and sort by datetime. And then we could reuse that different places. The point is that compute allows you to compose things very easily, and it has become a really powerful concept. So I just want to mention like change detection. Like how do we know that a component needs to re-render? In Cerebral 1, we depended on immutability. So all the state of your application was immutable, meaning that whenever you did a change inside the state tree, it would bubble up through all objects and arrays, and it would change their reference. So when, and then it will tell all the components that something happened in the state tree, grab all the state you have defined, and see if it has changed. And that's actually a very simple implementation. It's very easy to do this. Like immutability is that's just something that works. And then we just have to push an event or emit an event to all the components, and they will figure out, do I need to change? And they do that very fast, because since the references has changed, it can just check if, okay, has items changed, like the array or the object itself, and then render if it has. The problem with immutability, though, is that JavaScript doesn't have immutability. And there are many different implementations of immutability, and all of them is relatively slow, especially if you have like 1,000 items and you want to put that into an immutable list, for example. It's actually quite slow. And also, like one of the like more popular immutable libraries, Immutable.js, doesn't allow you to work with objects and arrays like you usually do, like just using dot to get values or point to properties and stuff. You have to use this. You have to use methods for everything, and that's not ideal. We don't want to force people into that kind of API to manage state and values. And also, it's not ideal related to list optimizations. And the reason is that if you change an object in a list, the list itself will change. Like I talked about this bubbling up. So when you render a list and you have a component for every item in the list, it will actually render the list as well, because the list has changed because a child of the list changed in the state tree. So it's just not ideal. But hey, like immutability is a really great concept, and I really hope it becomes like a native part of JavaScript, so we don't have these cons for using it. So maybe Cerebral one day will change back to immutability. But for now, we have a mutable state tree, like technically a mutable state tree. But during development, it just freezes everything. So you're not allowed to make manual mutations. You have to use the state API to do so. But when you get the state in your components, you just use it as normal. So how does Cerebral figure out when a component should render? And it does that with something we just call dependency tracking. And the cool thing is that when we have a single state tree and every state change points to a path in the state tree, we can just list these paths. So whenever we do a mutation, it's related to a path. And all the components, they point to specific paths they depend on. So we know that if there was a change to a path, it doesn't matter what kind of change it was, then we know there's a change on that path. And we know what components depends on specific paths, so then we can tell those components to render themselves. So it's more, we detect changes by path changes, not by reference changes. Yes. And the cool thing about that is there's no performance hit on that, because we just mutate objects and arrays as normal, like it's just plain JavaScript. And it gives us some new optimization possibilities, because we can now express that, for example, this component renders a list, and we only want to re-render this component if there is a change on the items in the list. Like if there's a new item or an item has been deleted, that is when we want to render. So if I, for example, change an item in an array, only the component depending on that specific item will re-render. It won't bubble up the changes and make other components re-render as well. We can actually more in detail decide what should render and not render, which is important sometimes when you have huge lists and stuff. The cons of this approach is that it has a bigger memory footprint because it needs to keep track of all these dependencies, but like it doesn't matter. You're not going to get a memory issue with your app with this approach. Yeah, so that's how that works. And then we have the signals implementation. Like in Cerebral 1, that was like the big experiment, and it was an internal implementation. But what we saw after the release of Cerebral 1 is that we can move this signals implementation into its own thing. And we actually call it function tree, because signals are really just calling a function, but instead of running a single scope, like a single function, it runs a tree of functions. So Cerebral 2 actually extends function tree. So it's kind of like a wrapper around function tree, where it adds the concept of modules and something we call providers and stuff. And the cool thing about function tree is that it's a very basic implementation, and you can use it for lots of different things. You can even use it on the server, which I will show you later. What's new with this function tree is that we have this explicit concept of a sequence and sequential and parallel execution, which gives us the ability to name compositions. So if you have a signal that uses different parts of other signals, you will actually see that in the debugger, and I will show you that shortly. What's even more awesome about this is that we can actually merge client-side and server-side execution. And in Cerebral 2, there is an implementation of this with Firebase. So I'm going to demo that for you now, I think. Yes. So you get like a graphical impression of Cerebral 2. Okay, so this is our project, like at the startup I'm working at. And this is like in development, so I'm not going to show you stuff here, but I'm going to refresh this, and we're going to jump into the Cerebral debugger. And now this is the standalone edition of the Cerebral debugger. Now it's a signed Mac application. You can use it on Windows and Linux, and it uses WebSockets to communicate. And it needs to do that because it also works with function tree, so you can debug on the server, or with like a native app or whatever. You can still use the Chrome extension, but we are doing more and more stuff with the standalone debugger. Now, the point is that when I refreshed the application, it triggered a signal called challenge routed. And what we see down here is all the mutations and side effects that happen when this application loads. And as you can see, it's quite a bit of stuff that happens. And this is not cerebral complexity. This is application complexity. This is what it actually has to do. This is the data it needs to get. This is the state it needs to handle to show this page. So we can shortly go through this. What we can see here is that we're using operators. We can read these declarative tags inside the debugger, so we get a lot of information. We know what properties has been passed in to this signal. We know what output one of these operators give. We can see, let's go down here. We can see that we have composed in a sequence here that is called authenticate. So authenticate is most likely, well, it is its own file with its own kind of like its own sequence declaration, and we have named it authenticate. So when we bring this into the signal of challenge routed, we can see that in the debugger. which is pretty awesome. And we can see that authenticate composes in sign-in, which is a different sequence. And we can see that happens when we get a user. So get user calls a side effect called Firebase get user. It outputs a user that it's not redirected to the success path, and that has composed in the sign-in sequence. So you get all this information about how things run. And as you can see, it's pretty complex. And usually when we debug this is like really great to get insight into what's happening, but usually we are after some specific state path, for example. So what we can do is we can say, okay, let's find something. I want to know what happened to app.isAuthenticating, for example. I can say app is authenticating, and it will actually highlight this state path in the signal. So I can see when the mutation was done, and I can see it in the context of how the flow happened when the page loaded. And I can also see its position in the, well, I did write the path, so I could easily find it in the state tree, but it highlights it automatically. Okay, so that is how that works. And on the right side, we see the state tree, of course. And we can investigate that, we can change the state and all this cool stuff. But what I want to show you now is how we merge client and server-side execution. So our application uses Firebase, and we run Firebase tasks in Node. So the client asks, inserts a task into Firebase, and our service picks up that task, runs it, and resolves or rejects it. So when I click this notification thing here, let's just look at it. We can see that it did some state mutations, and then it ran a side effect called Firebase task, check notifications. And in line with this side effect, we can see what happened. This is actually inside Node. So inside Node, we ran a signal or a function tree execution called check notifications. What it did first was to authenticate. It was a success. It grabbed the profile from Firebase. We can see that it outputted it. We can see all the information about it. And it was a success on updating last seen notifications, and it resolved. And then it was a success on the client. This is actually insanely powerful. Being able to see, like, on the abstraction of your application, like the flow of how your application works, it's immensely useful for understanding and building this mental image of how your application works. Okay, so let's just quickly go through the rest here. We also have a mutations tab now, so you can see all the mutations chronologically. Like a signal can run actions asynchronously, signals can kind of like run at the same time. But here you actually see mutations in a chronological order. You can time travel if that's your thing. And you can click all these paths to figure out, like highlight them in the state tree, and you get all the details about of the state mutations. And here also you can, do this highlighting stuff. We also have components. So we list all the active components in the app at this moment and what state paths they depend on. And we also have a render log that shows you what components, what state paths were changed and what components were affected by those changes. And this is something we plan to iterate more on now because we have more time to do it. So there will be some changes to this section of the debugger as we move on. As a final pointer here, it is now possible to add multiple apps. So like here is the Ducky app, and I can hit plus here, and I could add Webpack bin, for example. And that's running on port 8484. And I could say this is a pure Cerebral client-side app. It's a pure function tree app. or I can say it's both. So Ducky would be both. Now Webpack bin is just a pure Cerebral client, so I click add, and now I have Webpack bin debugging here, and I can click to Ducky like this, so it's very easy to switch between them. Cool. Okay, I need some water. I think I've been talking a lot. I hope you follow me all the way to this point. I'm really looking forward to the Cerebral 2 release. We've been working on it for months, like since the release of Cerebral 1. And there's been so much feedback, so many contributions. The whole code base has been refactored to encourage contributions, and it has really worked. We also have a new website that you can find on, maybe I can just type that quickly in there, cerebral.github.io. So this will be the official website when we launch. We have done tons of iterations here as well, so it should be cleaned up a lot. And of course, we have webpackbin.com, which is actually running on Cerebral 2 in production right now. So, which is a pretty cool service. Sweet. Thanks for taking the time to listen to this preview, and hopefully you will try out Cerebral 2 when it's released. Bye bye.